A heavy rainstorm delivering millions of gallons of water to a forest is a display of immense physical impact. The scale of the event raises a specific question: where exactly does all of this falling water come from? From our perspective on the ground, the answer is simple. Rain falls downward from the clouds floating above us. But that observation doesn't explain the physics of how thousands of tons of liquid water move from the ground into the atmosphere to fill those clouds in the first place. The reality is that Earth's water exists within a closed, never-ending biological and atmospheric system known as the water cycle. We can map the mechanics of this system across 4 sequential steps: evaporation, condensation, precipitation, and collection. Analyzing this loop shows why water on Earth never truly disappears. It is simply in a state of constant transition between different locations and forms. The cycle begins with the vast bodies of liquid water covering the Earth's surface, our oceans, rivers, and lakes. To move this water into the atmosphere, the system requires a primary power source, the sun. The sun emits thermal energy that constantly increases the temperature of the top layer of these water bodies. This thermal transfer drives the first major step of the cycle, evaporation. As the water heats up, it undergoes a physical change, transforming from a liquid into a gaseous state called water vapor. In this gaseous state, the water is no longer visible to the human eye. Because water vapor is lighter than its liquid form, it naturally rises, carrying the water high into the surrounding air. Evaporation essentially functions as an anti-gravity mechanism, using solar power to lift Earth's surface water into the sky. Once airborne, the invisible water vapor continues to ascend higher into the atmosphere. However, at these higher altitudes, vapor encounters a significant environmental shift. The surrounding air temperature drops significantly. This cold air pulls heat away from the rising vapor, causing it to cool down rapidly. This cooling process triggers the second major step, condensation. As the gas loses heat, it changes back into microscopic droplets of liquid water. These new droplets cluster together in the sky to form the shapes we see from the ground. When billions of these microscopic droplets combine, they become visible as massive clouds. Clouds are massive floating reservoirs constructed entirely of condensed liquid water. As the condensation process continues, more and more water droplets are pumped into the same cloud structure. Inside the cloud, these tiny droplets collide and merge, forming larger and heavier drops. Eventually, the cloud becomes so dense with large drops that it can no longer remain suspended in the air. This leads to the third step, precipitation. Gravity pulls the heavy water mass back toward the Earth's surface. Depending on the local temperature, this water returns as liquid rain, solid snow, or icy hail. Precipitation is the atmosphere's return mechanism, forcing water back to the surface once it reaches a specific weight threshold. We can now track that falling water as it reaches the Earth's buried surface. This return to the ground is the fourth step, collection. In the most visible form of collection, water flows across the terrain to gather in rivers, lakes, and oceans. A significant portion seeps directly into the ground, absorbing into the soil. This water settles into underground layers known as groundwater. Whether stored on the surface or deep underground, this water eventually settles into stationary bodies. Collection serves as the staging phase, providing the stable pools of water needed for the sun to begin the heating process again. By viewing the entire landscape at once, we can see how these isolated stages form a single system. The sun powers evaporation, lifting vapor into the sky. Condensation cools that vapor to construct clouds. Precipitation returns the water to the surface, and collection gathers that water back into the reservoirs where the journey began. Because these 4 physical steps link together, the water cycle operates as a self-sustaining planetary loop. Operating within a closed loop means while the cycle is continuous, it never creates new water. The total volume of water on Earth is constant. We are using the same supply that has circulated for billions of years. This makes water a strictly finite resource. Every living organism relies on the specific pools of water currently moving through this cycle. Because we cannot manufacture more water, we must protect the collection pools we have. Contamination or waste in our rivers and groundwater reduces the only supply available for the next turn of the cycle. Protecting our water is a necessity for sustaining life, as every drop is an irreplaceable part of an infinite shared journey.